Hello everyone, welcome back to Math with Allison. Today we're continuing our series on integration, so specifically we're going to be talking about indefinite integrals and trigonometry. So let's go ahead and dive into it. I have the list of all of the derivatives here that we are going to be using today. So we have sine, cosine, and tangent along with their inverses. So we've already gone through the derivative unit. We know how to take these derivatives, but I want us to realize that if we know the derivatives, we also know the antiderivatives. So all this knowledge that we learned is not a waste. We are going to be still using it. So if the derivative of sine is cosine, then what we do is we switch the values. So now we're going to go ahead and take the antiderivative of cosine, and our solution is going to be what we took the derivative of. So this is going to equal sine of x. But don't forget, we have to add on some constant c because the derivative of a constant is 0, yada yada. So this process follows for all of these values. So I'm going to go ahead and fill all these in. So let's go into some examples here. My trick is to always convert everything into sine and cosine, because if I look at this first integral, I don't know how to take the antiderivative of a product, first of all, cotangent times sine, but I also don't know how to take the derivative of cotangent. So if I were to rewrite everything in terms of sine and cosine, this would become cosine of x divided by sine of x, and then that sine of x stays the same, so I just multiply it in. And now we can see the purpose of this is that the signs cancel out. And so all this becomes is the antiderivative or the integral of cosine of x in terms of x. And just looking back at our rules, we know how to take the antiderivative of it. It's this first one right here, and this becomes sine of x plus some value c. So that's how I suggest we solve for antiderivatives. I also have another suggestion where you check your work. The reason I say that we check our work is because it's really easy to make a simple mistake because we're so used to working from derivatives, which we move forward, and then all of a sudden we're switching to moving backwards. So we make mistakes, and that's totally okay, but that's why I suggest we check our work. So here what we do is we take the derivative of our answer. So when I take the derivative of this, I get cosine of x plus 0. I'm not going to write that. And what we're checking for is that if what we get right here is what we're originally taking the antiderivative of. And if those two match, then we know for sure that this is our solution and we're good to go. So a simple check can go a long way because sometimes you could drop a negative sign. You realize that you accidentally did the derivative instead of the antiderivative. Stuff like that. So let's go ahead and try another one. Of course, we're going to go ahead and rewrite this in terms of sine and cosine. So that cosine on the outside stays the same, but I'm going to change what is going on in here. So that becomes sine of x divided by cosine of x plus 2 over cosine cubed of x. So we just did some trigonometry. Now we're going to do some algebra. So let's go ahead and multiply that cosine of x in. Okay, so we did some algebra. Let's go back to trigonometry. I'm going to go ahead and rewrite the second term. So this becomes the antiderivative of sine of x plus 2 secant squared of x. So let's take the antiderivative of these terms. So if we go up, the antiderivative of sine is equal to positive cosine. But notice there's a negative out here, which means in our solution, we need to add a negative right here. So this becomes negative cosine of x plus 2. Remember, scalar multiples just hang out there. And if we go back to up here, we have the antiderivative of secant of x is equal to tangent of x. And then plus some value c. So let's go ahead and check our solutions. And this is what I'm talking about. We could miss a negative here or something. Super common, and that's totally okay. We're human. We make mistakes. So that negative hangs out, but the derivative of cosine is equal to negative sine of x. And that 2 also hangs out, and that becomes secant squared of x, and the derivative of c is equal to 0. So let's go ahead and rewrite this. This becomes positive sine of x plus 2 secant squared of x plus 0. So I won't write that. And let's go ahead and check it with our actual antiderivative. So this totally matches with what we took the antiderivative of, which tells us that this is going to be our solution. Let's go ahead and try one more. This one's a bit more tricky. We have 8x and 2x in there, not just a normal x. Let's go ahead and rewrite everything. So first, that sine of 8x totally stays the same, but now we're going to multiply by cosine of 8x divided by sine of 8x. Hopefully you guys are picking up on a pattern here. Things usually cancel out. I don't know why math teachers like to trick us, but whatever. It's teaching us critical thinking skills. and problem solving skills, right guys? You can really just think of it as like a giant puzzle, you know? You're just solving a puzzle. Don't we all love puzzles? Or am I just an old lady? Okay, so I made a previous video about this if you want to check out why this is happening. But when we take the antiderivative, first let's go ahead and think about this cosine. The antiderivative of cosine is going to be sine, and then that inside stays the same. But when we take derivatives, we would multiply by 8, right? Because we multiply by the derivative of the inside. When we do integration, we divide. So I'm going to go ahead and divide by 8. And now I'm going to do the same thing on this one. So the antiderivative of sine is negative cosine. And now instead of multiplying by 2, I'm going to divide by 2. And then I'm going to add on some value c. So let's go ahead and rewrite that to look a little bit nicer. Okay, so we have a solution here. We want to make sure that this is actually our solution and we didn't forget anything. So let's go ahead and take the derivative of it. Okay, the derivative of sine is cosine. The inside stays the same, but we multiply by the derivative of the inside, and then that scalar multiple just hangs out. Okay, let's do this again. Plus, and now the derivative of cosine is negative sine. Multiply by that 2. We're going to keep that 6 down there, and that's going to be plus 0. So let's see what cancels out. The 8 cancels out. That becomes a 3 in the denominator, and I'll go ahead and rewrite this. Okay, so let's go ahead and make sure this matches. So we have this whole thing right here, and we took the antiderivative of this whole thing. So that totally does match, and that tells us that this whole thing right here is our solution. So that's all I have for us today in this video. If you enjoyed it, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, please give this video a thumbs up and comment other topics or problems you'd like to see done. Thanks for watching.